This is Brandon McCullum with Material and Energy Balances, Homework 1, Part C. In this video, I will be implementing into code a nonlinear regression for the Antoine equation and finding values for the coefficients A, B, and C using this temperature and vapor pressure data. So the first thing we want to do to import this data is go ahead and copy that permalink and type in wget -N -Q and paste in our link. We want to replace this blob and set of numbers and letters with just main. And if we go ahead and shift enter, we can see that it did work. Now that we have that, we want to import numpy, and from scipy.optimize we want to import our minimize function. The next thing is to read our data, so np.loadText, water vapor pressure .csv, and our delimiter equals apostrophe, comma, apostrophe. We can see here that we do have our array. Now I actually want to separate those parts from each other. So we will go ahead and write that in as a variable and then separate by using temperature and vapor pressure variables, pvap_data.t. And so now if we go ahead and type t, we can see we have all of our temperature values, and pvap we have our vapor pressure values. The next thing we want to do is go ahead and define our function. I am calling it Antoine SSE because we will be finding the sum squared error of this Antoine function, and it has a vector component which will be A, B, and C, the Antoine coefficients. Right. To find the error, we need to first create a model, right? And that will be our 10 to the power of A minus B over T plus C. This is just our Antoine equation. So now what we can do is return the sum of all the values of the model minus the vapor pressure data squared. That's our function, and now we are going to try to derive the A, B, and C coefficients by using the minimize function. Minimize Antoine SSE, and we put in 3 guesses. We'll go ahead with 10, 1000, and 30. And unexpected EOF while parsing. I forgot a parenthesis here at the end. And okay, now we have this, and we can see there was overflow in both the power within the model and the square in the return function. This is just because the data is too large. So what we can do instead is turn this vapor pressure data into the log of itself, right? So we'll use np.log10, and if we go ahead and copy this function, we will rename it log of Antoine SSE. Now that we have computed the logarithm of all of our vapor pressure, we can now remove this 10 to the power of in the model, and in our return function we will use log of the vapor pressure instead of just the vapor pressure. If we go ahead and minimize this, we can see optimization terminated successfully, and we have our A value, our B value, and our C value. I will now be going to the board to show how we can derive a linearized transformation of the Antoine equation and find a decision matrix that we can then implement into code. Now on to part 2. We have our Antoine equation, the log of pressure vaporization equals A minus B over T plus C. Right, and to linearize this, we will multiply both sides by T plus C. So we have T plus C times the log of pressure vaporization equals T plus C times A minus B. Right. So next we can distribute that to T times the log of vapor pressure plus C times the log of vapor pressure equals AT plus AC minus B. Now, here we have an equation, but we can see that we have one of our terms we're solving for, our C coefficient, on the left side, separate from these other Antoine coefficients. So what we want to do is, now for this next section here, we will be using our decision matrix to solve for the Antoine coefficients. Right, so we had our matrix, and we will go ahead and write that in as np.c underscore, followed by our matrix. So the first column was all of our t values, the second was our negative log of vapor pressure values, and the third was a column of ones, which we will write in by using np.ones underscore like t. Right, and so that will give us the same number of ones as the number of t values. The next step is, if we go ahead and write that in as matrix A, we now have to solve for our values. We will do this by writing in A, C, and D, and going at np.linalg.solve A dot, so the transpose of A times A, and the transpose of A times our time times log of vapor pressure, which was our right side of the equation. Alright, and if we do that, we can see when we print A, C, and D, we have our values, but we don't want D, we want B, which we define D as AC minus B. So we now need to write in B equals AC minus D. Right, and now when we put in AC and B, we have our Antoine coefficients. We'll write it in ABC, and comparing that up here, we can see we have very similar values for each one. And that is all for homework 1C. Thank you.